Okay, so now question 4. In the diagram below, a circle with center B, which has A and B, BP is parallel to the y-axis with point P on the x-axis. So BP, this line here is parallel to the y-axis, which is this one here. And what's the statement saying again? With P on the x-axis. Okay, cool. And then AS is a tangent to the circle B at A. So AS is a tangent, so this line here from this point up until that point, it is a tangent, right? And we are given point A, which is this one here, is given as -2 and 4, and intersections and intersect the x-axis at S. So the same tangent intersect the x-axis at S, right? And the y-axis at R. AE is a tangent to the small circle, so this AE from this point up until that point is also a tangent, but to the small circle with center D. So there is a center D there, and touches the circle at E. So this tangent touches the circle at E. ORS is equals to 45 degrees. So we are given that this angle here is equals to 45 degrees. Fine, so we're having our two circles here, and we're told all the tangents that lie in these two circles. This is a tangent for the bigger circle, and this is a tangent to the smaller circle, right? Cool. Now, the first question says that we must find the equation of the tangent of AS. So we want to identify the equation of this tangent here, AS, right? So to find this equation here, we already know that this equation has an angle of 45 degrees. So if it's 45 degrees here, it's going to be 90, and here it's going to be negative 45, but you can just write add that 45 degrees, just say 180 degrees minus 45 degrees, you're going to get 135 degrees. So which means the angle of this line here, so you're going to subtract this 45 degrees here, meaning this part here from this portion up to this portion, it's 135 degrees. So now we know the angle of inclination of the line of AS is 135 degrees, right? So if you write it properly, it's just this one here. So if we write it properly, this is the angle of inclination, which is 135 degrees. Cool. So for us to find the tangent, we have to use the angle of inclination, which is going to be tan of theta is equals to the gradient, right? So we'll be able to find the equation of AS, and we'll also use the point of A to actually find the equation of the tangent. So to find the equation of AS, we know A, the coordinates of A given as -2 and 4, and we are told the angle of inclination of this line, as we calculated, it's just going to be 135 degrees equals to theta, right? So tan of theta is equals to m, right? So we want to find the gradient. Why? Because the equation of a tangent is equals to mx plus c, right? So we first have to find the gradient, then we'll find the value of c. So it's going to be tan of 135 degrees equals to m, right? So if you punch in your calculator, tan of 135 is going to give you -1, so meaning the gradient it's -1. So you're going to say y is equals to minus x plus c, right? And then you're going to substitute point A of -2 and 4, right? So meaning you have y is equals to minus x plus c, and substituting these points here, you will have Where there's y, put 4, so it's going to be 4 is equals to, where there's x, we put -2, so it's minus into -2, plus c is going to be 4 is equals to negative multiplied by negative, gives you +2, plus c, transpose the 2 to the other side, you have 4 minus 2 equals to c. 4 minus 2 is 2, so c is equals to 2. So the equation of this tangent of AS is equals to minus x, right, because we got m as -1, and plus 2. So this is the equation of this tangent of AS. So now the next question, so we're done with this one here, 4.1. 4.2, we are told that if OP is equals to 4 units, so let's go to OP. This point here, from here to the origin, distance from here to here, if is equals to 4 units, right? Okay, cool. Determine the values of A, B, the center of the larger circle. So we are asked to find the coordinates of this larger circle. If we are told that the distance OP is 4 units, right? So what we're going to do is, since we are told the distance from O to P is 4 units, so it's easier to find the x value, right? Because from here to here, it's actually A according to this center of this circle. So meaning our A value is simply -4, because this is the negative side of x, right? So we already have our A being -4. So now the whole point is to find this value of B here. So to find our coordinate of B, now that we have the coordinate of A being equals to -4, we need to note something here. We have this line of AB, right? And we want to find this value of A here. So we know very well that this AB is perpendicular to this tangent of AS, right? Why are they perpendicular? It's because it's tan perpendicular to radius, right? One of your theorems. So they are perpendicular, meaning that if lines are perpendicular, it means now that the gradient of AB, when you multiply it with the gradient of the line of AS, it must give you -1, right? And we already know the gradient of AS. We calculated it in a previous question, and we found to be equals to -1, right? So if we were to calculate it, so we know the gradient of AS being equals to -1, and we know that m of AS multiplied by m of AB is equals to -1. So -1 times m of AB equals to -1. So you divide by -1, divide by -1, m of AB is equals to 1. So now we know the gradient of AB. Remember, we want to find the value, the y value of B, right, which is the center of the circle. So we know the gradient. So the whole idea of finding the gradient is so that we can use it in the equation of the gradient, which is equals to m is equals to change in y over change in x, right? The reason why am I using that, it's because if we're going to use these 2 points here, we're going to use this point here of B and this point of A, right? And we already know the gradient of these 2 points. So, and we know this value of A, we know this value of, and we know this value of B, of A rather, the x value, and we know this value here. We know all the values here, and we just need this value. So you're simply going to use the gradient to find the value of B. So this is what we're going to do. We're going to say, okay, fine, we have A, which is -2 and 4. So this is how we're going to do it. So we have A, which is -2 and 4, right? And we have B, which is A and B, right? And we know the value of A, we just found it to be -4 since we're given 4 units. So meaning now that we have -2 and 4, and we have B, which is equals to -4 and B, right? and we just noted that the gradient of AB is equals to 1. So if we use the equation of a gradient, which is equals to change in y over change in x equals to y2 minus y1 over x2 minus x1, right? And we know that the gradient of AB is 1, so it's 1 is equals to, so the y2 we can simply say y of b minus y of a over x of b minus x of a, right? The y of b is this one here, which is b, the one that we're looking for, right? And minus the y of a is 4, so it's going to be 4 divided by x of b, which is minus 4 minus and x of a, which is minus 2, so it's going to be minus 2, like that, right? So we know it's 1 is equals to b, and then minus 4 over minus 4, so this negative and this negative will multiply, we have plus 2, right? So it's going to be 1 is equals to b minus 4 so it's going to be 1 is equals to your b value, right? Minus 4 over minus 4 plus 2 is going to be minus 2. Then you cross multiply, you have minus 2 is equals to your b value, right? And minus 4, so you transpose the minus 4 to the other side, you have your b value being equals to minus 2 plus 4. So this means now that your b value is equals to 2, since minus 2 plus 4 is equals to 2. So this is your solution of b. So now we're going to do 4.3. It says that determine the equation of the circle with center B. So remember that we found the coordinates of B, which is A and B, like that, and we found them to be A value is minus 4 and B value is 2. So these are the center coordinates of the circle, the bigger circle. So we need to find the equation of that circle, right? If you take a look, the only thing that we have here is the center and the point. So we have the center, which now b is equals to the a value, which is minus 4 and 2, and we have this point here of a, which is minus 2 and 4. So we're going to use those two information to find the equation of the circle, the bigger circle with center of B. So as I said, we have our coordinate of B, which is minus 4 and 2, right? And coordinate of A, which is equals to minus 2 and 4. So we're going to use this to find our equation. We know the equation of a circle is x squared plus y squared is equals to r squared, right? Inside the x squared, we're going to write x minus b. Or let me just say, since we know our values, so this is the value of x, right? So I'm just gonna say x plus 4, right, squared. Why? Because this x value here, it's x equals to 4, so it's x equals to minus 4 rather. So it's equals to minus 4, meaning when you take this minus 4 to the other side, you have x plus 4 equals to 0. So now it's a factor, so you write it as a factor, hence I wrote x plus 4. Then plus your y value of the center is 2, so it's going to be y minus 2 squared equals to r squared. So for us to find the equation of a circle with center B, we are not complete until we find our r, right? So to find our r, we're going to substitute our point, which is our point A, which is minus 2 and 4, right? So we're gonna substitute, where there's x we put minus 2, where there's y we put 4. So here it's going to be minus 2 plus 4 all squared plus our y is 4 minus 2 all squared equals to r squared, right? So minus 4 plus 2 is going to give you 2 squared plus 4 minus 2 is going to give you 2 squared equals to r squared. So 2 squared is going to give you 4 plus 4 equals to r squared. So 4 plus 4 is 8, so 8 is equals to r squared. So now this is our r, which is r squared is actually equals to 8. So to find or to write our equation now properly, we're going to say x plus 4 squared plus and y minus 2 squared is equals to 8. Why 8? Because this whole portion is equals to r squared, so our r squared is equals to 8. So this would be our equation of the circle with center B. So now we go to 4.4, which says that the equation of the small circle is given as this one here with center D. So it has a center D, the small circle. Write down the equation in the form of this here. So we need to deal with this using completing of the square to actually write the small circle equation properly. So the small circle is this one here with a center of D. So the first thing that we're going to do is we're going to write the equation properly. So it's x squared minus 2x plus y squared minus 2y, right, equals to 0. So what we first need to do here is complete the square. So let's first solve this portion here. It's going to be 1 over 2 multiplied by the b value all squared. So it's 1 over 2 multiplied by our b here, it's minus 2. So it's minus 2 all squared. So minus 2 and 2 will remain with minus 1 all squared, right? So meaning when I have x squared minus 2x, then we're gonna plus, so it's gonna plus the minus 1 squared, and then we subtract it again, minus 1 squared, right? And then we write our y squared minus 2y, right? So we're gonna do the same thing here for the y value now. I'm gonna say 1 over 2 times b all squared, 1 over 2 times, what is our b here? It's minus 2, also it's minus 2 all squared. So we're gonna have minus 1 squared, right? Because it's negative 2 and the 2 will cancel out. So it means now that we're gonna add the minus 1 squared and subtract it again here, minus 1 squared. So the entire equation is equal to 0. So what you need to do is we need to factorize this portion here. So you have x squared minus 2x minus plus 1 rather, because the minus 1 squared will give you a positive. So and then you have minus 1 here plus, so this is plus y squared minus 2y plus 1 minus 1 equals to 0, right? So as I said, factorize this, you're gonna have x minus 1 all squared, and then you have this minus 1 here, you're just gonna write minus 1 plus, and factorize this portion here, you have y minus 1 all squared, and then this one here you write it as minus 1 equals to 0. So you're just going to transpose this minus 1 and this minus 1 to the other side, which is this side here, and you will remain with x minus 1 all squared plus y minus 1 all squared equals to, so the minus 1 when it goes to the other side it's going to be plus 1, so it's going to be positive 1 rather. So I'm just going to write it as 1 plus another 1, so because this is negative 1 and negative 1, going to the other side is going to be positive. So our equation is going to be x minus 1 all squared plus y minus 1 all squared equals to 2. So this is our equation with center D. 4.5 says that write down the coordinates of D, the center of the small circle. So remember that D is actually in 4.4 we were told that it is the center. The center of D is actually this equation here, right? It has a center of D rather, and we found the equation with the center of D to be x minus 1 squared plus y minus 1 squared equals to 2, right? So we found this equation. So now we want to find the coordinates of D. So it's just simple. We're going to take, because D is the center, so center of this circle here, So you're just going to write this minus 1 transpose to the other side is going to be positive 1. This minus 1 transpose to the other side is going to be 1. When I say transpose to the other side, if you have x minus 1 is equals to 0, so you transpose the negative 1 is going to be x equals to 1. Hence I wrote x equals to 1 here. And then you have y minus 1 is equals to 0. You transpose the minus 1 to the other side, you have y is equals to 1. So hence I wrote 1 here. So these are your coordinates of D, which is 1 and 1. So now 4.6, we are asked to calculate the length of AE, the tangent to circle D at E, right? So this needs us to go back to our diagram. So let me clear our diagram so that we are able to see clearly on what's going on here. So we are asked to find the coordinates of we are asked to find the length of AE, right? So for us to find that length of AE, let's first draw this triangle here. So we're having a tangent that looks like that. So it's the tangent of the smaller circle, and then because we want AE, which is this line that I just drew, it's what we want. We're having a triangle. I'm gonna form a triangle that we're having here. So you're having this and it joins there. So what you need to note is this triangle is, so this triangle that I just drew has a right angle here. Why? Because tangent is perpendicular to radius, right? So it is a tangent. So our AE is what we are looking for, this side here, the distance, but we know DE. Remember, we just found we know DE to be what? We just found our equation of the smaller circle being x minus 1 squared y minus 1 squared equals to our r, which is 2, right? So this is the radius, right? DE is actually equals to the radius of the smaller circle. So what's the radius of the smaller circle? Here it's 2, right, which is r squared equals to 2. So to find the radius, we square both sides, so r is equals to root of 2. So it means now that DE is actually equals to root of 2. So this is equals to DE. So it's the length of DE. So we have this length to be equals to root of 2, right? And the length of AD now, we need to find that. So for us to find the length of AD, we know the coordinates of A, we know the coordinates of D. So let's find the length of AD. Once we find the length of AD, we're going to use Pythagoras theorem to find the length of AE. So let's do this on the other side. So we know the coordinates of A being equals to, if we take a look, it's minus 2 and 4. So the coordinates of A is minus 2 and 4, and the coordinates of D it's 1 and 1, right? And as I said, if you draw the diagram, it's like that. It's like that. So your A is here, your D is here, and your E is here, right? We're looking for this side. We know it's right angle here. This is root of 2. We want to find the distance from this point up until this point. Let's first find that. So the distance of AD is equals to the root of, so let me write it properly, the root of x2 minus x1 squared plus y2 minus y1 squared. So this would be your x1, this is y1, this is x2, this is y2. So I'm gonna write that inside here. So it's going to be equals to the root of x2 being equals to this one here. So it's 1 minus x1, it's this negative 2 here, so it's going to be negative 2 like that, all squared, plus your y2 is this one here, which is 1 minus this 4 here, so it's 4 squared. So it's equals to the root of minus 2 times minus 2 is positive, so it's 1 plus 2 all squared, and plus 1 minus 4 squared like that equals to the root of 3 here squared plus into minus 3 squared, right? So you're having the root of 3 squared is 9, so it's 9 plus 9 being the root of 18, right? So this is the distance of AD, right? 18 units. So now we just calculated the distance here, which is 18 units. So now we want to find this distance here of AE. So we're just simply going to use Pythagoras theorem, r squared equals to x squared plus y squared, of which our r squared is equals to AD squared equals to, and then our x, we're going to take the DE squared plus our AE squared, which is what we're looking for. So AD is equals to root of 2 all squared is equals to our so AD, which is this side that we just calculated, this one here, is equals to root of 18, right? So it's going to be root of 18 all squared equals to our DE, which is what we know here, being root of 2 squared plus AE squared, which is what we are looking for. So we can first find the answer. The root of 18 all squared is going to give you 18 equals to the root of 2 all squared is going to give you 2 plus AE squared. Transpose the 2 to the other side, we have 18 minus 2 is equals to AE squared, which you'll get 16 equals to AE squared. And find the square root of this, you're going to have AE being equals to 4. So you're going to have AE being equals to 4. So it's plus or minus 4, but because we are looking for a length, we're just going to take a positive sign. So it's 4 units. So this is the length of AE.